Hello and welcome to Tomorrow's Tech by IDTechEx. I'm your host, Dr. Tess Skirm, and in this podcast series, I will be interviewing an array of industry experts on emerging technology from IDTechEx. IDTechEx is a market intelligence company with a mission to provide clarity on emerging technology. And in each episode, our analysts will be discussing all kinds of topics, everything from virtual and augmented reality hardware, autonomous vehicles and flying cars, sustainability and energy storage innovations, medtech and wearables, 3D printing, advanced materials, and so much more. In each interview, we're going to explore what the future outlook is for each of these technologies, as well as endeavouring to find that elusive insight into hype versus reality. On today's episode, we have got Sona from IDTechEx joining us. She is their resident 3D printing expert. Welcome, Sona.
Thank you for having me, Tess.
No problem. So, Sona, tell us before we get going just a little bit about yourself and how you came to be involved in this world of 3D printing.
Right. So, my background is actually originally in material science and engineering. Studied it during my bachelor's and my master's. And it was during that time that I really got a sort of awareness of how big the 3D printing world was. That it is more than just, the hobbyist with their printer in their home. And more importantly, like how involved materials are in the 3D printing world in terms of, like, it's not just a thermoplastic filament that you use, and you can use so many things in 3D printing. And so once I got a sense for that, I sort of really just got into it through research and then eventually by joining IDTechEx.
Yeah, wonderful. And you've touched there exactly where I wanted to start, which is that my only exposure to 3D printing was the kind of novelty-esque plastic printers in university labs where we would kind of print small toys or key rings or something like that. So, and I imagine that's the same for a lot of people. So perhaps as a place to start, if you could just set the scene of the 3D printing industry today, kind of what is the scale of it? What are people making? What are they making it out of? And how has it developed beyond that hobbyist place that it began?
Yeah, and so I guess the place to sort of start is to establish just how old 3D printing is. It's a little bit over 30 years old as a technology field, and originally started up very much in the industrial realm, not the hobbyist realm. So for a long time, 3D printers were very much restricted to a smaller group of industrial users who actually understood how they could use it. But then there came a point in the early 2010s where a few key patents expired, thus just blowing the field up to anyone who wanted to enter it. And that's where you saw that hobbyist segment all of a sudden explode. And so that hobbyist segment, which is primarily those smaller 3D printers, sometimes they come pre-assembled, sometimes they're a kit that you assemble yourself. Typically, they can cost anywhere from like as low as a couple $100 to as high as like a high almost $1,000. But those hobbyist printers, there's millions of those being sold every year across the world, especially since it's started to boom in the early 2010s. And so that's the most like, visible segment of 3D printing by this point. But as I mentioned before, 3D printing started a little bit more as an industrial tool, and it very much still is today and is actually significantly expanding in the industrial segment now.
That's so interesting. I had absolutely no idea that there was an industrial precursor to the kind of hobbyist 3D printing. So just to kind of stick on that for a second. So what was the first kind of products, or what was the first use case of 3D printing in industry before it was in university labs and people's desktops?
So fundamentally, 3D printing used to be called rapid prototyping. And prototyping as a key use case for 3D printing is still very much there in the field. So that's exactly where it started. It's just being able to prototype things first from just purely maybe like a design perspective, like what's the shape to look like, maybe colors or other things. And then maybe expanding a bit more out to, okay, maybe we can test a little bit more of the functional properties with these prototypes made via 3D printing. And so prototyping is still a massive part of 3D printing in both the hobbyist segment and also in the industrial segment as well. But now where you see the industrial segment starting to push that more and more and more to try and make this more than just a tool for prototyping at the very start of any given product's lifespan.
Yeah. So can you give a couple of examples of which industries are using it for rapid prototyping? Is it kind of automotive, consumer electronics, or kind of what's the main sector that is adopting it?
Oh, I mean, practically every major sector you can think of is using 3D printing for some sort of prototyping activity. Some of the historically biggest sectors have been just the manufacturing sector. You have automotive, you have aerospace, medical, which historically are three really big high-value fields for 3D printing. But as well in the consumer goods space, you have people prototyping there, as well as just utilizing these in education as well. That's also quite a big vertical in itself.
And is the main advantage of it in the name of rapid? Is speed to getting to prototype the main kind of benefit of using 3D printing, or are there other advantages as well?
Absolutely. So I think the primary first benefit was in the speed to achieving that prototype. Previously, when you wanted to prototype something, you would often have to send it out for specialized, shops who can manufacture that prototype, because you couldn't use something like injection molding for like one-off prototypes. And this was, time consuming and just annoying for the people who are trying to prototype something relatively quickly. So first and foremost, it's the speed to achieving the prototype. But then you also have these benefits in terms of the shapes. So now with 3D printing, you can create geometries that might have been otherwise unachievable via other types of making prototypes. And so now you have this whole expansion in terms of what you can prototype, because both speed and shape / size are now all sort of maximized for you because of the new technology you have at hand.
Just a question on that one, because I've seen that one of the benefits is that you can do these more complex geometries. How does that then translate to if you want to scale up the manufacture of this prototype, but you've depended on 3D printing to obtain this complex geometry? Is that then a bottleneck in scaling up the design, or am I missing something there in terms of the process?
No, yeah, it definitely depends on, how complex the geometry is. There are certain geometries, like if you think of lattice structures, that are really only achievable via 3D printing. So if you want to scale, you have to use 3D printing for it. And so that sort of idea then gets factored into the very beginning of whatever product you're manufacturing. Is like that idea like, oh, I'm going to have to use 3D printing to try and manufacture this. And for that reason, some people or some users inherently, limit the volumes of whatever part they're trying to make with this lattice structure, because producing it on scale, let's say millions, might not be super realistic, at least in a timely manner, because additive manufacturing, which is, our other term for 3D printing, is not necessarily as fast as your classic injection molding, CNC machining, or some other more mass scale production methods. On the other hand, you can use 3D printing to get shapes that are achievable via mass scale production, so let's say injection molding. It's just that it's harder to do on a smaller scale, on a prototyping scale. So 3D printing helps you make a product that is very similar, if not exactly the same, as the product you're trying to manufacture at the end.
So you touched before on where industrial use was going and how it was evolving from rapid prototyping. Was there more that you wanted to expand on that front? And is it about kind of new types of rapid prototyping, or is it about using 3D printing for mass manufacture more broadly?
A little bit of both. So for sure, mass production using 3D printing is the holy grail. That's difficult to achieve in a lot of applications right now for a variety of reasons. It started from the fact that most 3D printing methods are just inherently slower than, say, injection molding, machining, other types of subtractive manufacturing. And so with that inherent bottleneck, you had people sort of experimenting with their 3D printing technologies, adjusting them to try and make them more suitable for mass scale production. And so you have increased adoption of what we call powder bed technologies now, which I consider to be the most suitable 3D printing technology segment for mass scale production. And so when I say powder bed technologies, what do I mean? I mean, yeah, what in the world is powder bed? So, what most people think about in 3D printing is you taking a little thermoplastic filament traditionally, you're sticking it through a nozzle, you're heating up that nozzle, which then extrudes that plastic, and then you sort of move it layer by layer to build up a part, right? In powder bed, you're changing out quite a few things. Your feedstock, instead of using this thermoplastic filament, using some sort of powder. It can be a thermoplastic powder. It can also be a metal powder if you want. And that powder is placed evenly on a bed. At this point, you then take some sort of energy source or binding agent. So for example, you could take a laser and then layer by layer, selectively sinter or melt the particles on that powder bed. And if you do that continuously, so let's say you laser one layer, and then you spread another layer of powder on top of that, laser that layer, and you do that bit by bit, you can then get a whole part built from a powder bed. And it's just the inherent sort of features of that process make it sort of easier to scale in terms of how many sort of parts you're trying to make on that powder bed. And also a little bit faster than your classic thermoplastic filament extrusion. And this applies to both metal and polymer. Additionally, I should mention, there's a second type of powder bed which people think is very interesting for mass manufacture. And that is sort of relying, instead of using a laser, to sort of cinch these powder particles together, which then makes layers, which then makes a part. It's relying on some sort of binding agent that you're dropping. You're dropping it all over this powder bed layer, and then you're putting another layer of powder on top, and then you're dropping more binder on top. And that binding agent, which you then sort of fix with thermal radiation or sintering afterwards, that also helps you build a part quite quickly, and quite in a more energy efficient way, since you're just dropping binder everywhere rather than using a whole laser. Yeah. And so those are two sort of main powder-based technologies, and people are looking at that for mass scale production now.
Yeah, that's really fascinating, and I think there would be few people that connected 3D printing to kind of lasers, powders, and binding agents, having seen just the usual, as you say, thermoplastic filament style of device. So is that method, is this powder-based method, is that an R&D phase technology, or is that actually being adopted anywhere for commercial use cases?
Oh, we're seeing it now being very much adopted for more commercial use cases. I don't know if necessarily you call them mass scale production. I think the highest volumes I have personally seen has been in and around like the tens of thousands of parts.
Okay.
So definitely higher volume than obviously a one-off prototype. But it's still not like quite mass production in that sense. But there's plenty of sort of prominent users of those types of technologies. So, for example, there's a automotive supplier that used a machine from a very famous manufacturer of that type of device, HP. They use that to make somewhere around 50 to 60,000 replacement parts for a specific automotive vehicle.
Right.
Okay. There are others who are using that for custom footwear. There are others additionally who are using it to help make sort of tools and jigs and fixtures, which is another category of application I haven't really mentioned yet, but is one of the biggest application areas for 3D printing, is using 3D printing to make tools, jigs, and fixtures that support manufacturing of other devices as well. So that exists as well.
Yeah, just a couple of questions have sprung up with that answer. The first thing was custom footwear. Tell me more about 3D printing for custom footwear.
So I don't know if you've seen them around, because they do definitely exist, but the idea of custom footwear using 3D printing is that obviously everyone would like their shoe, particularly sneakers, to be custom shaped to their foot. That does not happen and is not sort of achievable with just typical methods, because how are you able to take everyone's custom measurements? You'd have to typically just do it manually, and then that has to be sent somewhere, but then how do you then sort of custom make a shoe to those measurements? At that point, you're getting into just bespoke footwear, which is not at all achievable on a mass scale for the average population. Nowadays, with digital technologies, you have a much more achievable route to doing that for a lot more people. So essentially, you can go somewhere, you can have your foot sort of scanned, where they're taking your measurements quite quickly. And then those measurements could be sent to some sort of shoe manufacturer. And that shoe manufacturer will be using 3D printing, first to rapidly sort of take your measurements, turn it into a 3D model, which is then printed by whatever technology they pick. It depends on what they want to use. They could be using a powder-based technology, like I discussed. They could be using a resin-based technology, which is a whole different field. And depending on what they do, they're able to print out, and sole for you, like a midsole and insole, or like the bottommost sole as well, using 3D printing. And the benefit of using this is not only the sort of custom shape you can get, but also the fact that 3D printed part can have a nice lattice structure, so then it really conforms nicely to your foot as you're stepping on it. Supports you well, rather than just being, let's say, like a big old plastic block on your foot.
So who's wearing these 3D printed custom footwear? This probably stems from the fact that I talk about wearable technology a lot, but this seems like a bit of a pro athlete type market to me. Is that where it's going, or is it kind of got more healthcare use cases? Who are the customers for this stuff?
I think definitely athletes is where this started out, because they could really benefit from a custom footwear shape. There are, I think, moves to try and, as the sneaker market expands, I'm sure you've noticed over the past several years that sneakers as a fashion object is massive.
Yeah.
So there's now attempts to sort of take it a little bit more mainstream now and allow access to this and to more and more people. But I definitely see the athletics field as sort of the first sort of adopters of that and the biggest beneficiaries of it.
Yeah.
But I think in the healthcare space, there is this idea of applying 3D printing for custom orthotics as well. It definitely exists. I'm not sure as to the scale of it yet.
Sure.
But incidentally, actually, I should mention my bachelor's thesis project back at the University of Pennsylvania centered on this idea of integrating 3D printing with sensor technology for for healthcare orthotics applications. So it's definitely a space that exists and there's a lot of experimentation with, but I think athletics is where it more is currently is versus, everyone having custom footwear to support the arch of their foot, for example.
Yes, sure. So then the other side of the coin, then going well away from consumer footwear and back to the industrial use cases. So why on earth is a 3D printer a good thing to use to make industrial jigs? I did not see the connection there initially.
So the big thing is that for the scale that a lot of these jigs, tools, fixtures are at, they aren't very cost effective to produce via traditional manufacturing methods. So sometimes you just might want like a few hundred or in the low thousands of these jigs or fixtures or whatever. Sometimes way less than that. And producing it via traditional manufacturing is just not very cost effective at all. Plus, you have that whole timing issue that you also have, as we mentioned before, with traditional manufacturing. So 3D printing comes in and fills this gap where you could produce quite a few of them, but much quicker and much more cost effective. So that's where 3D printing has sort of swooped in and to make that field a little bit, faster in terms of making these tools, jigs, and fixtures to support these manufacturing activities.
Yeah.
And it also supports more iteration of these sort of devices. Sometimes you just need to try a couple of times to get the right tool for the manufacturing process that you have.
Right.
And 3D printing supports that really well in a way that it's both fast and also has less waste than some of the other technologies.
Yeah. So it just comes back to the main value proposition of 3D printing, I guess, which is an accelerated kind of design iteration cycles is part of that. And then, just faster prototyping. Something I wanted to move on to was thinking a bit more about, it comes back to actually kind of the public perception of 3D printing and also just considering perhaps where the hype is in this industry. And I caveat with saying that I think hype can be both a positive and a negative word. So negative in that if something is overhyped, that's obviously not generally a good sign for new technology or for an investor. But similarly, hype is important in terms of raising awareness and helping to build funding and kind of build branding and everything else. So considering all of that, is there, in all of the conferences that you've been to on this and all of the research that you've done and people that you've spoken to, is there a particular area that you think has historically been overhyped for 3D printing?
I mean, we can start with the fact that 3D printing as an industry has definitely undergone sort of the hype cycle. Especially when it first started getting significant visibility in the press and in the public consciousness, about 10-ish years ago now. You would see articles everywhere that was like, you'll be able to 3D print your organ, or you could 3D print your phone, or whatever.
That was I was kind of hoping you would say, because I didn't want to kind of reveal my own naivety, but there was definitely a time when there was lots of discussion around you're going to be 3D printing your food in your kitchen, you're going to be 3D printing new organs, they're going to be the new inkjet printer in everyone's home will be the new 3D printer. So
exactly.
Can you speak to, is it the case that those use cases were just naive to what the technology's killer apps were really going to be, or is that something that is just always going to be 50 years away?
It was very much a sort of naivety born of a lack of understanding of the actual practical challenges of using 3D printing. You have to have knowledge of first how to obtain or how to make 3D models. You need to be able to optimize those models for 3D printing. And then when you 3D print something, you have to be able to troubleshoot, because there are practical issues that happen when you're 3D printing something. And all of those things were just sort of ignored in this idea of like everyone can have a 3D printer, because the reality is that it is a specialized manufacturing technology and does need a little bit of training, more than a little bit if you're applying it to more high-end applications. And so the idea that everyone would have it to be able to make so many different things is a little unrealistic, to say the least. Now, one thing that happened during that sort of hype phase is that you had loads of not just like hobbyist users, but also like sort of higher end users, like actual manufacturing companies or aerospace companies or medical technology companies, so on and so forth, buying 3D printers in the hope of applying it towards a certain application or being able to all of a sudden transition, some applications to 3D printing. And again, that was sort of born without a whole lot of introspection or, clear idea of how the actual practical challenges of 3D printing might affect its adoption by those companies, right? So you had this period of time where loads of people were buying 3D printers, more industrial and 3D printers too. And then because of this lack of knowledge of all the practical challenges of implementing 3D printing, we're not able to utilize it to its fullest extent. And that resulted in a sort of little bit of a disillusionment phase in 3D printing where everyone's like, well, we have this 3D printer, we're not using it for anything. Like, what can we use it for? Is it actually useful? So on and so forth. Those types of things. And nowadays in 3D printing, when you go to conferences, I think the industry is so much more realistic and forthcoming with the actual challenges that need to be overcome in 3D printing to get it to be used in some of these very high value verticals. You'll hear in the messaging in the keynotes in a conference, and like, let's say Rapid, which I attended this year in the States. I attended Forum Next Forum, Austin, just a month and a half ago. And that messaging is quite clearly there, and the industry is much more honest about it. But there's definitely this period of time where, loads of different high-value industries thought, oh, we could use 3D printing for loads of stuff, and then maybe bought in without sort of realizing it. And now there's a sort of challenge where everyone's like, well, why should I be looking at, not everyone, rather, these high-value end users are like, well, why should I, pay attention to 3D printing when I was a little bit burned before or other people were burned? Like, how is it actually valuable to me? And how can I make it valuable in my supply chain?
Yeah, I guess that's probably born from as well is that if my competitors are looking into it, I need to be looking into it, and you can kind of jump the gun before having actually developed a good use case, and that's not the technology's fault.
Exactly. It's always a messaging thing with any emerging technology, and 3D printing definitely went through a phase of having to refine its messaging and also refine its understanding of what end users needed. It's much better now, and you see it in the conferences where end users are now presenting on what they're actually using with 3D printing. So.
Yeah. And I guess on the other side then, so what have you seen that is perhaps an area that has been historically underhyped, or something really cool and exciting and a novel use case that you think is one to watch? Anything like that that you come across?
I think so let me start off with telling you what the hyped areas are first. So 3D printing for aerospace, medical, and automotive have historically been very hyped. People have been trying very, very hard to apply their 3D printing tech in those spaces. And it's because of how valuable those spaces are. In the case of like aerospace, the sort of performance demands of aerospace means that it could make very good use of the new geometries and other aspects that 3D printing could introduce. And in the medical space, it's the sort of different customizations that 3D printing could introduce to medical devices, and as well as, being able to create surgical tools and models. So there's historically been a lot of hype around those three spaces. However, the reality of applying 3D printing in those spaces is a little bit more difficult. You do see it for sure being used, but the high standards of certification, qualifications, validations that you have to undergo to be, applied in those spaces means that it takes actually a long time for 3D printing to sort of enter any given application and then be subsequently be applied as an end use.
Yeah.
So outside of those sort of historically very hype spaces in the 3D printing world, I think there's definitely some interest as 3D printing to really help expand manufacturing activities. Like we've mentioned tools, jigs, and fixtures. And I think it's very much prominent in those spaces. And it's growing in its prominence because there's this realization by the manufacturers that like, oh, we can use it to enable all sorts of things and make manufacturing for other fields a lot easier. So definitely in the manufacturing space as well. I think, in my opinion, in the energy space, speaking broadly in the energy space. So this includes oil and gas. It includes renewable energy, like let's say wind. There's a lot more sort of understanding of how 3D printing can not only serve those spaces on a manufacturing end, but also in a sort of on-demand repair end. when things go wrong for energy applications that might be sort of positioned in far out environments.
Oh, wow, okay.
3D printing could theoretically be used to support the repairs or spare parts needed in those environments. And I actually heard this more recently in a conference presentation I attended by a major oil and gas player, how they use it to sort of help support their installations that are in very remote locations. So I think the energy spaces will be really interesting in the future of 3D printing, especially with the incentives in place, just like on a broader governmental scale.
Yes.
To improve and expand the scale of our renewable energy infrastructure.
Yeah. I get the other thing that I'd seen in the news I wanted to ask you about was, again, in my wearable technology world, waves were slightly made when it was announced that kind of Apple were now going to be kind of looking more seriously at 3D printing. So what can you tell me about that announcement and how it's impacted the 3D printing world?
Yeah, so Apple, at one of the major conferences in China for next South China, they announced their use of a specific 3D printing technology called binder jetting. If you remember, I sort of introduced this when I described the powder-based 3D printing technology that uses binding agents to build a 3D printing device. Binder jetting is the name for that. And Apple announced their use of binder jetting, specifically metal binder jetting, to make the frames of a bunch of their smartwatches. And this made huge waves in the 3D printing world. I can promise you that. Because, these sort of consumer devices that have much higher volumes has always been one of the holy grails of the 3D printing world. And for Apple to come out and say, yeah, we are actually using it for this particular smartwatch application was massive.
Okay.
Now, what is a little bit sort of less clear is the extent to which they will be using it. Right. Is it, just for a certain sort of, line in the Apple Watch space, or are they going to be using, titanium 3D printing for, the entire next generation of Apple Watches?
Okay.
It's slightly unclear at this point, but it's really exciting that they are seriously considering.
And do you think the timing of it is to do with the maturity of the binding? Sorry, what is it? Binder jet?
Binder jetting.
Binder jetting. So is it the maturity of binder jetting and the fact that it's at a readiness level to cope with higher volume applications that has made it tempting for kind of the consumer electronics space? Is it kind of a tech pull, or do you think is there another driver?
I think it's a little bit of, there's two different drivers in this case. So for sure it's the maturity of binder jetting at this point, where it very much can be applied to all sorts of higher volume applications. It was fundamentally binder jetting as a technology was designed to be utilized for medium to high volume applications. That's really where it came out of. And so, the maturity of that technology is definitely a factor here, but it's not like it hasn't been mature for at least a few years. What has been coming more to the forefront is A, awareness of binder jetting and its maturity, but B, also significant disruptions in more traditional supply chains around the world. Okay. So you'll note that the sort of announcement of Apple using binder jetting for their Apple Watch sort of line, that happened in Formnext South China. And the disruptions that have been happening, first and foremost, out of South China in traditional manufacturing supply chains that have sort of had ripple effects across the world, has without a doubt made lots of different players, sort of consumer goods players, but also other players, seriously consider looking at 3D printing for their manufacturing activities. And it's because 3D printing inherently doesn't need to be in China to be cost effective. It can be, like Apple is doing it.
Yeah.
But it also can be done elsewhere across the globe. And, for companies that are looking to sort of future-proof their supply chain, if you will, future-proof them from significant disruptions, especially those in China, that might completely derail their activities. 3D printing is a really attractive asset for that. Because it doesn't need to be in any given location to be scaled and to be utilized effectively.
Yes, I mean, that's so interesting and brings me on to the last couple of questions I wanted to ask you about, which is looking into the future. So what are your expectations for the next 5 to 10 years in the 3D printing industry?
So I think in the next 5 to 10 years, the 3D printing industry, the entire ecosystem will be really significantly maturing to make the use of 3D printing as easy as possible, especially for industrial end users. So when I talk about the ecosystem, I'm referring to the fact that 3D printing is never just the 3D printing. The 3D printers have expanded and have been continuously maturing for years now. But what you need for 3D printing to be applied on industrial scale is not just those 3D printers being a mature technology. You need 3D printing software. You need 3D printing materials that can be applied towards all sorts of applications. You need post-processing equipment that can help you, finish a 3D printed device in any which way you may want. You need all sorts of specialized training and people with the knowledge of how to appropriately use and apply 3D printing. And so you also need quality assurance where, 3D printed devices may not be perfect. How are you monitoring for that so that it can be applied in cases where quality assurance is really, really, really important? And so that entire ecosystem is currently maturing to allow people to use 3D printing industrially in an efficient way. Because I would say, you go back a few years, every individual manufacturer of a 3D printer had their own sort of siloed ecosystem. They might have their own software, they might have their own post-processing equipment, their own materials that you had to use with their 3D printer. And so 3D printing was just a ton of different islands where all these manufacturers are existing in their own islands. Now there's better awareness in the industry that this is not actually the most effective way to get people to adopt 3D printing. It's not actually the most user-friendly approach. It doesn't take into consideration the individual needs of any given industry. So now there's a lot more open collaboration and sort of development happening to allow for a workflow to be developed involving 3D printing in loads of different industries to sort of integrate 3D printing very effectively into current supply chains. Doing that is not a straightforward task, and so I would say this is like sort of the focus of the industry right now. And, what you'll see in the next 5 to 10 years, like the maturity of that coming to fruition.
Yeah. I mean, it's been great to learn about how diverse this industry is. And I think we've come a long way in our understanding about how it is developed and how it differs from the kind of the general public's probable perception of it as a bit of a novelty tool. I know that you've done so much research about the kind of the detail and the supply chains of the 3D printing industry over the years. So my final question to you is just what topic are you going to be looking at next, and what's your future work on the 3D printing industry going to be focusing on?
So the way I've chosen to look at the 3D printing industry is from a material-centric perspective. So in our IDTechEx research portfolio, we have a 3D printing overarching industry report, which looks at some of, the individual material sort of verticals, so polymers, metals, ceramics, for example. But I've also decided to expand into reports on each of these individual material verticals because I think the challenges for each of those material verticals are quite specific and require their own individual discussion. So I have reports now on metal additive manufacturing, polymer additive manufacturing, ceramics, composite additive manufacturing. And I think my next sort of research steps is really understanding sort of the end user needs in a lot of these high value industries. So let's say energy or manufacturing or aerospace or medical or etc. Is sort of really looking into those end user needs, because already I've collected a ton of info from the conferences I've been attending over the past year or so. Now it's about formalizing all that information I've gathered to really give a good view for people who are in the 3D printing industry of the exact most important challenges they need to overcome for those high value users to consider adopting 3D printing more. And so that's sort of my next steps, basically.
I can't wait to read about it. And I've also been persuaded that we definitely need to do more 3D printing wearable technology crossover discussions, because between the smartwatches and the footwear and the other things we've talked about, there's clearly a lot going on, and we haven't even touched on 3D electronics and printed electronics and all of that. So
exactly, it's
plenty more we can get into. Oh, well, thank you so much for your time today, Sona, and look forward to speaking to you again in the future.
No, thank you so much for having me, and excited to talk again about this.
Thank you so much for listening to Tomorrow's Tech, hosted by IDTechEx. IDTechEx offers independent market intelligence on emerging technologies. For more detailed information on this topic and many others, please go to idtechex.com, where there are dedicated research reports on the emerging technologies we cover, as well as articles and free-to-attend webinars.